Welcome and hello, I'm Brian Dail, Danfoss's Air Conditioning Segment Marketing Manager in North America. I'm here to talk about future-proof technologies for chillers. Feel free to ask any questions in the chat and we'll get to them at the end of the presentation. The future of HVAC and chillers is connected to the industry's interlocking trends of decarbonization, electrification, and energy efficiency. Buildings account for more than 40% of energy consumption. Cooling sector accounts for 8% of global greenhouse gas emissions, and lower GWP refrigerants and energy efficiency can deliver more than 38% of the Paris Agreement. This is why governments and corporations are going to be focusing on buildings and energy efficiency there as a way to reduce overall greenhouse gas emissions. Going forward, electrification of heating is going to be important. Currently, HVACR is responsible for 17% of world electricity consumption, and with electricity from heat pumps expected to substitute oil and gas, there will be a increased load on the electrical grid. Large heat pumps could deliver 30% of district heating, so there will be potentially some needs to increase the electrical grid's capacity and transmission capability. And heat pumps are more efficient than combustion fossil fuel heating, so that will reduce emissions on its own, and that can be charged even heavier by electrical grids investing in green and renewable energies to further reduce carbon emissions. Chillers have a set of minimum efficiency standards set out by ASHRAE 90.1 and AHR 550 and 590. The efficiency standards vary based on the compression technology and how heat is rejected. And when looking at efficiency standards, they're both concerned with the full load efficiency of a chiller, and they're also looking at the part load efficiency. And both have to be met for a chiller to be at the minimum efficiency required. However, the future of chillers probably isn't just meeting a basic efficiency level. Building performance standards are controlled by states and localities. They all are going to have their own sets of requirements that they'll impose. And in contrast to minimum efficiency standards, these are going to be oftentimes significantly higher. I've got on the screen a set of states and localities that have either enacted mandatory building performance standards or are in the process of enacting them. It's easy to improve efficiency and to mandate improving efficiency on new buildings, but by making mandatory building performance standards, you can require that all buildings in that area have a certain efficiency standard, which is going to drastically increase demand for higher efficiency equipment in these localities. And in addition to what's just shown on the screen, there's many localities and states that are either banned new natural gas hookups or are considering doing that in the future. New York City, for instance, has banned new natural gas hookups in 2023 and 2027, depending on the size of the building. And this will lead to a big increase in demand of heat pumps and other all-electric technologies to replace commercial boilers. The AIM Act has been passed, and the AIM Act authorizes the EPA to regulate HFCs. HFC production and consumption is going to be phased down over a 15-year period. The EPA is authorized to establish standards for the management of HFCs. So this includes how to track, ship, and sell refrigerants, but it also allows them to enact segment controls on the HVAC market and refrigeration market at that. And the EPA is expected to enact sector regulation to require a GWP on air conditioning refrigerants below 750 on January 1st, 2024, and that's for chillers. This will put it in line with CARB, which has already had that rule on the books for a little while to have refrigerants used in chillers below 750 GWP. Going forward, there's going to be many potential refrigerants at play. It's a complex picture. On the chart that you can see, there is a y-axis that's showing different GWPs of refrigerants, and there's an x-axis showing their density, which also correlates to how high their pressure is. And in this arena, there's a lot of different options for lower pressure refrigerants that'll be in screw and centrifugal chillers. In the higher density areas, there gets to be fewer options. So on the screen, there's a line that indicates where all refrigerants below it are going to have at least an A2L flammability, meaning safety concerns will have to be taken into account with regards to those refrigerants. Our vision of refrigerants for chillers is that there's going to be a variety of different ones coming down the road. So currently we've got in screw and centrifugal chillers, R134A as being a main player for that. And in very large chillers over 500 tons that are potentially running at a vacuum, R123 is also seen currently in the US. In scroll chillers, R410A is king for air conditioning. Now, in the midterm, starting in 2024, for large and centrifugal chillers and screw chillers, we expect refrigerants like 1234ZE, 513A, and 515B to be the primary refrigerants that are being converted to. And in very large chillers that are going to be at a vacuum, 1233ZD seems like it's the best option. In scroll chillers, and that's also going to include scroll heat pumps, R32 and R454B seem to be the two primary refrigerants that are being looked at. Those two refrigerants are both A2L, so they're all going to have some amount of flammability concerns to go along with them. And looking ahead out even farther, Europe is looking to convert to even lower GWP refrigerants, potentially below 150, starting in 2024 to 2026. 1234ZE is a refrigerant that already is in that area of low GWP, and the same goes for 515B. So it seems like those refrigerants will be around for a long time. And when it comes to lower pressure refrigerants, 1233ZD is a great option, as well as 514A. Longer term, in the scroll chiller segment of the market, there are no high pressure refrigerants that look like they'll be able to hit that below 150 GWP mark. So as a result, it looks like some of the lower density refrigerants like 1234ZE or 515B may have to be adopted in that segment, and that would mean that scroll chillers would have to design around using lower pressure refrigerants. In Europe, R290 is a option, especially for heat pumps. And while it does come with flammability concerns, it could be an option for the US as well, particularly if the chiller is located outside, where the flammability concerns will not be anywhere near as big of a problem. The cost challenge. Moving to new technology is going to create challenges for both manufacturers and building owners and contractors. Development costs of new chillers is going to be relatively high because there's going to be a lot of new refrigerants coming into play, and they're going to be going across multiple different product lines, screw, scroll, centrifugal, and manufacturers are going to be hard pressed to come up with new products as well, because they're going to be developing heat pumps, many of them for the first time or with limited experience in developing heat pumps. So it's going to put a large development challenge on the equipment manufacturers. When it comes to initial cost for a building owner, typically only 10 to 20% of the overall cost of the chiller's lifetime is going to come from the price of the chiller itself. So it's important for a building owner to maximize their dollars per ton, or I should say minimize their dollars per ton to maximize their dollars power. The initial cost shouldn't be the only thing considered, and a initial cost could sometimes be offset by utilities that are offering incentives to use higher efficiency equipment. Building owners should also look at service costs, because it takes a lot of preventative maintenance and unexpected maintenance on chillers over its full lifetime. It might seem obvious, but increasing uptime and reducing downtime of a chiller is very important to make sure you're getting the full value out of it. And when it comes to servicing a chiller long term, it's important to look at the refrigerants being used. Over time, current refrigerants are going to be phased down, and as they get phased down, their costs will probably go up and their availability might be harder to come by. So building owners will actually have to consider what refrigerant is being used because it'll have an impact on their long-term costs. Running costs, meaning energy efficiency or energy usage, is also very important. And depending on the facility's need from a chiller, how much running time there is on that chiller, and what the price per kilowatt hour is, efficiency can actually pay for itself depending on the technology and type of chiller selected. On the future of technologies for chillers, multi-refrigerant capabilities is going to be important so that there's flexibility in design and so that components can be used across multiple different refrigerants. Products targeting part load efficiency are going to be important to maximize the dollar per ton that a manufacturer can offer. High efficiency products are going to be important because of the push to lower emissions and to lower power usage. Oil-free technology can also be a future path for chillers because it will reduce maintenance costs and hopefully prevent downtime of chillers. Danfoss has a large portfolio that is able to hit 70% of the total cost of a chiller. We have the broadest portfolio out there. We offer a variety of compression technologies at various levels of efficiency. We offer heat exchangers that can do both air side rejection of heat and water side heat transfer. Danfoss offers drives that can cover compressors, fans, and pumps. There's also balancing valves that can control the water side. In refrigerant side controls, there's a variety of different mechanical controls out there, as well as more advanced electronic controls that can do anything from driving an individual component to controlling an entire system. Danfoss has an application development center in Tallahassee, Florida. This allows us to partner with our customers to prove out new technologies and make proof of concept of different new technologies in a variety of different HVAC equipment, but particularly chillers in our 150-ton room that's designed to accommodate up to 150-ton air-cooled chillers. The facility is prepared to operate with flammable and A2L refrigerants to allow us to help develop the next generation of air conditioning equipment. As a case study on the value that Danfoss can provide, we worked with a data center in the US that had 40 buildings and a central cooling campus. We worked with the manufacturer to have them swap out one of the 1,400-ton chillers with a chiller that used 7 Danfoss turbocore compressors, and they immediately saw a 30% energy savings. So as a result, they pulled out the other 2 1,400-ton chillers and replaced them with 2 more chillers that each had 7 turbocore compressors in there. These oil-free compressors are going to not only provide energy savings, but the service costs are going to be drastically reduced by not having to worry about maintenance on oil. So, in conclusion, Danfoss is a great partner in the HVAC industry working to develop new technologies out there. Feel free to join other Danfoss EnVisioneering Connect presentations later today. Also, we'll have them available to be viewed on demand. We'll be going into other segments of the HVAC industry and also deep diving into pieces of technology that are out there for new HVAC systems. And I want to thank you for spending this time with me, and I'll be happy to answer any questions you might have.